Today I'll talk about principle of dimensional homogeneity. What is that? It states that in any valid physical equation or relationship, the dimension or units of the physical quantities on the both side of the equation must be same. Now we can take one example. An example of the principle of dimensional homogeneity is demonstrated when you analyze the equation for the period of a simple pendulum. So here equation is t is equal to 2 pi root of L by G. Now according to the principle of dimensional homogeneity, so both side that dimension of that equation should be same. Now uh, here equation is t is equal to 2 pi root over of L by G. So t represent the period of pendulum, that units is time. Pi is a dimensionless constant. L represents the length of the pendulum, the unit is length, and G represents the acceleration due to gravity, length per time squared. Now on the left side, t represents the period which has dimension of time. On the right hand side, 2 pi is a dimensionless constant, pure number. So root over of L by G has dimension of L by t square. So that will give t. So which represent time. So both sides of the equation, the dimension are consistent. So we can say the equation is dimensionally homogeneous. Now we can take another example. So that example is here, that v is equal to root of 2gh. Now in this case we have velocity, gravitational acceleration, and height h. Now 2 is a constant, so that has no dimension. So we can express this quantity in terms of their fundamental dimension like mass, length, and time. So velocity has dimension of length per time, so L t to the power minus 1, and gravitational acceleration has dimension length per time square, so L t to the power minus 2. So height has dimension of length L. So on the left hand side have dimension of velocity L t to the power minus 1. On the other side, root 2 gh has dimension L t to the power minus 2 into L. So if we do the calculation, we will get that L t to the power minus 1. So as you can see, both sides of the equation have the same dimension L t to the power minus 1, which means that the equation is dimensionally homogeneous and consistent. So remember here, so this is L t to the power minus 1 to the power minus 1. Okay, so that I can, so to the power minus 1, and this is also to the power minus 2, so typo mistake. So that's it. So you know what is the principle of dimensional homogeneity. Thank you.